Example 13, find the interval on which this function is decreasing. So we're dealing with this function of x, and presumably as x goes up, sometimes the function is increasing and sometimes it's decreasing. Just to have a further look at this, I plotted the function here on GeoGebra, and you can see that as, let's make this a bit wider so we can see it more clearly. Here we are. So you can see that the function is increasing as x increases, and then here, as x continues to increase, as I move along the x-axis, the function is decreasing, and then at this point, the function starts increasing again. We're being asked for the interval on which the function is decreasing. So our answer is going to be from here. That's when the function starts decreasing, when x is minus 3, right? And the function continues to decrease all the time until this point here, when x equals 1. So we know from looking at this graph that the function is decreasing when x lies between minus 3 and 1. So as long as x is greater than or equal to minus 3, when x is equal to minus 3, the function is neither decreasing nor increasing. As long as x is less than or equal to 1, then in that interval, the function is decreasing. So we've kind of cheated, and we've used a bit of graphing software to help us. Let's ignore that now, and let's find the solution algebraically. So we're going to start with our function, which is f of x equals x cubed plus 3x squared minus 9x. And we need to know for what values of x the function is decreasing. So for what values of x the gradient is negative. Well, we can find a gradient function. We can find an expression for the gradient in terms of x, an expression for the gradient at any given point on the curve. So that's an expression for the gradient there. And we want to know what values of x make this gradient negative. So I'm going to solve this quadratic equation here. I'm going to start by taking 3 out, and now I'm going to factorize this more thoroughly. X and x. Let's have a think. I'm going to have plus 3 and minus 1 there. So that's going to give me solutions here involving x being minus 3 and x being 1, isn't it? Well, in this case, if x is greater than or equal to minus 3, and if x is less than 1, then the inequality is satisfied. So algebraically, I get a solution that the function is decreasing when x lies between minus 3 and 1, which reassuringly is what I also got when I considered the question graphically. Look, we can see the function does indeed decrease when x lies between minus 3 and 1. But here is the solution to example 13 algebraically.